Theorem class. Okay? First, we are going to remember what we already know. We already know that a right angle is an angle that has a measurement of 90 degrees and is represented with a little square. We also know that a right triangle is a triangle that has one right angle. And we also saw in class that a theorem is a statement that has been proven to always be true. Okay? There is no cases where this statement doesn't fit. And the last part of our review is the definition of the Pythagorean theorem. Pythagorean theorem says that the sum of the squares of the legs of the triangle, the legs are the two sides that are connected to the right angle, the square of both of them added together is always going to be equal to the hypotenuse. The hypotenuse is the side that is opposed to the right angle. Okay? Doesn't matter if we have the triangle turned to any side, the legs are always going to be the ones that are connected to the right angle. Now let's see. In order for the Pythagorean theorem be true, we have to be using a right triangle. If we are not using a right triangle, then the theorem will not be true. Knowing that, we will also know that if we use the Pythagorean theorem and it is not completed or it is not true, then the triangle that we are using is not a right triangle. That is called the converse Pythagorean theorem. When we have the sides of a triangle, we don't know the shape, and we want to know if it is a right triangle or not. Let's do an example. Let's say we have a triangle that has sides 10, 8, and 6. Okay? Out of these three sides, which ones are the legs? The 8 and the 6. Why? Because the hypotenuse is always greater than the two legs. Now let's see if this fits in the Pythagorean theorem. We have both legs to the square, and they should be equal to the hypotenuse to the square. 8 squared is 64 plus 6 squared, which is 36, equals 10 squared, which is 100. 64 plus 36 is 100 equals 100. This is true, so this is a right triangle. Next example, we have another triangle with sides 7, 14, and 17. Which ones are the legs? 7 and 14. Legs squared added will give us the hypotenuse squared. 7 squared is 49 plus 14 squared 196 equals 17 squared, which is 289. Let's add 49 and 196. 9 plus 6 is 15. 14. 245 equals 289. 245 equals 289? No. So this triangle, it's not a right triangle. With that, you can do the other two exercises that are on your presentation. And let's continue to the other exercises. Now, the distance between 2 points in the Cartesian plane. We have point 1 and point 2, and it is a line that connects both of them. Now we can add a point 3 to make this a right triangle. What is the measurement or the distance between point 1 and point 3? It is how much it moves in the x-axis. That is why the distance is the difference between the point x2 and x1. Now, what is the distance between point 3 and point 2, which would be the other leg of the triangle? It is the difference between point 2 and point 1, in the y-axis. Using the Pythagorean Theorem, we get this formula. Now, in order to prove this formula, we are going to do an exercise. Now, if we want to find the distance between point 1, which is in -3, 1, and point 2, which is 5, 4, first we are going to place them in our Cartesian plane. Point 1 is in -3 in x and 1 in y. And our point 2 is in 5 in x, 1, 2, 3, 4, 5, and 4 in y, which would be here. Next, we join the dots with a line, and we make straight lines that are parallel to the axis to get our point 3, and that way we can get a right triangle. This is our point 1, point 2, point 3. Now let's apply the Pythagorean Theorem first. What is the measurement of this leg? Well, we go from here to 1, 2, 3, 4, 5, 6, 7, 8. We have a length of 8. What is the length from here to here? We go from here, 1, 2, 3. We have a length of 3. Pythagorean Theorem says that 3 squared plus 8 squared, it's going to give us this distance we are missing, squared. 3 squared is 9, plus 8 squared is 64, equals b squared. This would be 73, equals d squared. We take the square root, and we get that since 73 is not an exact root, we get 73. The square root of 73 equals d. Now let's see if using this formula we get the exact same result as we did with the Pythagorean Theorem. The formula states the distance equals the square root of the difference between the two x values, which would be 5 minus negative 3 to the square, plus the difference between the values of y, which would be 4 minus 1 also to the square. The distance equals the square root of 5 minus negative 3 equals 8 squared, plus 4 minus 1 is 3 squared. The distance equals the square root of 64 plus 9. The distance equals the square root of 73. We have proven that we get the same result. Now let's use this same example to find the midpoint between point 1 and point 2. The midpoint would be the average between both points. Okay? So our midpoints would be a coordinate. We have x1, which is negative 3, plus x2, which is 5, divided by 2, comma, y1, which is 1, plus y2, which is 4, divided by 2. Our midpoint would be negative 3 plus 5 is 2 divided by 2, comma, 5 divided by 2. Our final result for the midpoint is 1, comma, 5 halves. This is our midpoint. This is the coordinate for our midpoint. Remember every time that if the result of the division is not a whole number, you must leave it in fraction form in order to avoid the decimals, because it's easier to find in the coordinate plane 5 halves. That is it for the class. Remember to log in for the Facebook Live Q&A to solve all your questions about this topic. Have a nice day.